So it's time to finally look at classes, or at least writing our own classes. I mean, we have been looking at them, we've been using them, the scanner class, the string class, the random class, the math class. We've been looking at different classes, we've been using the methods that belong to them, but now it's time to write our own classes, because that's really what programming is about. Not just using what's already there, but adding to it and creating some custom code. So we're going to start writing our own classes. So what are classes and what are the objects of those classes? Well, there's a lot of different examples, a lot of different metaphors that are used, but it really comes down to something where I want to describe a classification, and that's where the word class comes from. So I want to define, for example, a human. So I don't want to define a particular human, I just want to define humans in general. So there is certain things that humans have. We call some of them attributes, and those are the characteristics or the data or the values. For example, the color of your hair, the color of your eyes, the height, the weight of a human, the particular language that human speaks. So there's certain characteristics that that human has. And those are different between humans, but they all have the same characteristics. Also, humans have the ability to do things, and those are called the methods or the actions. For example, humans can walk, humans can talk, humans can eat, humans can move, humans can pick stuff up, humans can interact with other humans. So these are the actions that they can conduct. Not all humans have to carry out those actions, but all humans are capable of similar actions. And that's exactly what object-oriented programming looks at when it focuses on classes and objects. First, I'm going to define a classification of these are the things that all my particular attributes will be defined as within my class. These are the actions that the class will take out, and then I'm going to create instances of those. And so far, we've seen a very good example of this. One of the most common examples is the string class. The string class has particular attributes or data values, and that's the actual characters that a string stores. It also has methods or actions. So you can ask the string to return its values in uppercase or lowercase. You can ask it for the length of itself, and also a string can just easily display. So when you do a systemout.println of a string object, you don't have to individually describe the characters or pull them out. You can just say, I want you to display yourself. And the string class literally just goes ahead and displays itself. So there's nothing that strings can't do within themselves. They all have these capabilities. The only difference being between two string objects is the data itself. And that's a very important distinction to revisit, that classes define the particular attributes and the actions that an object will eventually be able to have and perform. But not all objects will have the same attributes, yet all objects will have similar actions that they can carry out. So the string class, they have individual characters that they store within them, but all string objects can perform the same actions. And that's essentially what classifications are defined as in object-oriented programming. So we're going to look at how we do that in Java. So there's some examples that the book has already provided for us. So if we look at these, we've got, for example, the student class. The attributes for any given student would be their name, address, major, and the grade point average. The operations that we can conduct with a student object would be being able to set their address, set their major, and also asking each student to calculate their own grade point average. So whatever that calculation happens to be. So if we had a group of students within a classroom, and I'm talking about a computer group of students, we could ask each student to set their address. We could give them their address to set. We could also ask each student object to calculate their grade point average. So that would be one example there. The next one would be a rectangle. This is a much simpler class definition example. So a rectangle class, each rectangle has a length, width, and color. So those are the attributes. And then we could look at the operations or the methods. We can set the length, the width, and the color of a rectangle. We could even think of an additional method could be give me back your area or your perimeter. So the rectangle could calculate its own area and its own perimeter. So we don't have to actually go through the math. The rectangle object could do that with its length and its width. They could perform those calculations. Similar with aquarium, flight, employee. Probably one of the common examples is that employee, because when we talk about computers, we end up talking about databases. So that would be a very common database that we would have, which would be an employee. So each employee has a name, department, title, and salary, amongst other attributes. But each employee object, there would be the ability to set the department, set the title, set the salary, and then we could ask each employee object, compute wages, compute bonus, and compute taxes. We can just put all that logic right in there, right in those methods for each employee. Now, if you think about what we've been talking about with methods so far, this is also an idea of encapsulation. So when we look at a student class, so students store the attributes that belong to students. We don't need to know anything else about where the geography is of where the campus is or anything like that. We're only going to store things that are student related. And the operations or the methods are only the ones that are related to the student. So for the student, we don't need to calculate how much tax uh, each department is going to be charged when they buy paper, because that has nothing to do with students. So if we look at a rectangle classification, if we create a rectangle object, each rectangle object will have a length, width, and color, and we'll be able to set the length and the width, and set the color, and maybe get the area and the perimeter. But the rectangle has nothing to do with the price of tea in a grocery store, because that has nothing to do with rectangles. So we're only going to store data and the attributes for rectangles and only perform the actions for rectangles. So that's an example of encapsulation. So one of the three tenets of object-oriented programming, we've got the ability to encapsulate. So we're putting only the things that belong to that class within the class definition. So uh, what can we do with these classes? Well, the idea is that it represents objects with similar behaviors. I mean, that's really what it comes down to. So I've got some examples there of a coin class, a student class, a message class. When we start getting into advanced programming, we want to send messages between objects or between computers. So with a message class, you could create an object which would have the message content, and you'd be able to set the message and also get the message back. So there's actually an unlimited number of examples you can do with this idea of classes and the objects that belong to them, because this is pretty much what programming is these days. So in general, describing a class, we've got a set of data declarations. We're going to commonly call those the attributes, and the method declarations. So defining all the various methods that that class has within it. So when we create an object of that class, the object will have this particular type of data, and it'll have these capabilities or these methods. So we've got two different ways to describe them. Actually, it really comes down to one. But essentially, if you look at it, we've got the attributes up here. So for whatever this object happens to be, it's got a size, a weight, a category, a value, and a cost of the different data types. So that would be the data for it. And then all the various methods that belong to that class. Now, of course, we don't know what this class is, but you can imagine maybe something that does a calculation with the size and the weight. Maybe this has to do with shipping. It's a postal classification. We've also got the value and the cost. So the cost of the item, or maybe the value of the item, the category is how we're going to ship it, and all the various methods that belong to that type of object. Now, commonly, this is a more familiar form right here, where we actually have a sort of a box or rectangle, and this will describe an individual object. Above a certain line, we're going to have the attribute definitions, and below that, we're going to have the method definitions. Now, it doesn't mean we fully flesh out the methods. We don't have to write all the code, but we're just going to define what the methods are. So if we had something like the string class, up above in the attributes, we would have the characters themselves that make up whatever information is being stored in that string, and we'd also possibly have the length. so that each string has its set of characters and the number of those characters, which would be the length. Below the line would be the methods, so that's where we would have something like string.length, which would return the length, string.toUppercase, which could return all the characters as uppercase, maybe a dot equals, so that the object could compare itself against another string and return back true or false. So we would have all the various methods laid down. Now that is commonly referred to as the API, or the application program interface, for that particular class. We need to know its attributes, and we also need to know its methods. Now, speaking of the string class, if we look over here, this is just a simple um, class definition that we've got straight from Oracle, looking at the string class. And there's just some stuff up here which is describing how the string is defined, how we can actually use it, some help for it. But if we go down a little bit further, you can come down into what we call the fields and the constructors. Now, in this format, and this is referred to as the JavaDoc style of formatting for a class, the fields themselves are what we've been referring to as the attributes, or the data that belong to that class. Now the string class, even though it actually does have some data, as we said, it's got the characters and possibly the length, we can't manipulate those directly. We can't actually change the length of a string. We can't just reach into a string that has only 3 characters and say the length is 17. The string does not let us do that, nor does it let us change the characters within itself. It doesn't have that capability. It's not part of the definition of that class. But if you look down here at the at all the methods, and we'll be looking at something like constructors soon enough, all of these are actually the methods. And now here where we get down into the proper methods for the class. So you can see we've got the char@, method, which belongs to it. The char@ method gets an index, so that's part of its method header or its signature, and it returns back a char, or a character. So this right here is the API for the string class. So everything you need to know about using the string class is all in here. And the string class has many, many methods. We've only used a fraction of them, but there's many, many methods that belong to the string class. So if you ever wanted to know what the string class is capable of, you just pull up this type of document. You just Google it, and there you go. You have the string class. You can do this for the scanner class, for the math class, for the random class. Anything you need to know about the class in terms of using it or calling its methods is done through the API. And this is all you need to know. The other aspect of the API, as we pointed out in this one, you don't need to have the full definition of the method. You don't need to see the code of how the method accomplishes it. The API, the purpose is to tell another programmer, here's how you use this class. You create it this way, you declare it, and then here's all the methods that you can use. You don't need to know how the methods operate. And that's part of the encapsulation as well. We're encapsulating the knowledge of how an object of a particular class accomplishes its work. But we don't have to advertise that. It's not important to know how a class accomplishes its work through its methods. At best, all we need to know is what are the methods. How do I call this so I can use it in my program? I'm a lazy programmer. I don't need to know everything. I just need to know enough to be able to use that particular method. So that's actually something that's one of the foundations of object-oriented programming, this idea of hiding stuff. And you might hear this as the term black box. So a lot of object-oriented programming concepts are surrounded with this idea of a black box. I have a black box in front of me. It accomplishes what I need, but I don't need to be able to see within it. It's locked, it's closed, it does what I want it to do, but I don't need to know everything. And I've always used the idea of a car that way. I don't need to know exactly how an internal combustion engine works or how the electric relays control all the various components of the car. I just need to know that this feature moves me forward. If I change this one setting, now I'm moving in reverse. And if I hit this lever, the car is eventually going to stop through the brakes. That is what I need to know to operate or drive the car. I don't need to know what metal was used to fabricate the engine block. It's not important for me to use the car. So let's take a look at a particular class. So the book talks about one called the die class. It's a very, very simple class, and all it really does is it defines, as it's indicated here, a single die. So dice is the plural where we have two of them. So a die itself, and commonly known as a six-sided die, so we've got sides that have 1, 2, 3, 4, 5, and 6 indicated, and you can roll it. And when you roll it, it should randomly, if it's a proper die, come to rest on one of the sides so that it shows at the top 1, 2, 3, 4, 5, or 6. So we're going to represent this within a class definition. We're going to call the class die, and it's going to be able to roll. So you're going to be able to ask the die to roll itself, and it will randomly pick one of the sides. So this is actually a very, very straightforward class, but it's also a very fundamental class because it uses a lot of the ideas of creating a class and creating objects without actually adding a lot of code. So when we looked at the string class, it just went on and on and on. We don't need to write all those methods for the die class. We need some very simple things. Essentially, roll the die and figure out what the roll result was. And that's all we need to know. So let's take a look at the API for the die class. So the die class, as pointed out here, is different from all the classes we've seen so far because the die class is not part of the standard Java API. So if you install Java on your laptop, you will not have the die class. You need to write this yourself. Now, once somebody has written it, for example, you could give your die class to somebody else. They can then use this class. But by definition, this is not part of Java. So we are creating something completely brand new with this class. So if we look at the API, we can do the first thing, which is create one. We'll talk about constructors, and that's where we just have the name of the class with no parentheses. So we can define a new object of the die class. You can also roll a die, and that's the second method here. So when you roll a die, all it does is it just randomly rolls the dice, and it returns back which face is facing upwards. So if you roll a six-sided die, you're going to have a face that's 1, 2, 3, 5, or 6. That's the value that'll come back. You can also set the value. So you could actually pick up a die physically and flip it to the appropriate side. So we have that feature as well with set value. So you can actually set the die face. Why would you want to do this? Well, the fact is, a physical die, you can roll it and it should randomly land on a particular side, but you can also pick it up and change its side. So we're trying to replicate that physical action. This is an object after all, so it might have a physical representation. You can also do a get face value, and what get face value does is it returns back the face value of the die. Now we've already done that with the roll. So when we roll a die, it does come back with the face. But what if you want to get the face again? So let's say you've rolled the die, you have the face value, but you want to do a systemout.println of the face value, but you didn't end up storing it in the roll. You just forgot to store that value permanently. So you can ask the die almost the same as looking at a die and saying, oh, its side facing upwards is 3. So I can do that. But you don't change the value of the die. You don't have to re-roll it. So you can do a get face value. Now the last one is actually something we're going to focus on a little bit later on after we've defined the die class. So it's called the method toString. This method is probably one of the most fundamental methods in Java when you're creating a class. What this does is it lets you, as the programmer, control how this object of this particular class, how the object can represent itself. So we have never actually used this before. Um, if we ask an integer what its value is, it'll return back an integer. If we ask a double what its value is, it's going to return back a double. Same with a char or a byte or a boolean, which will return back true or false. The primitive values return back exactly what they are. But when you ask a string object, what is it? it returns back its characters as a string, which is sort of strange, but a string returns a string. But the string class has the idea of toString. And what that means is that when you ask an object, what is it, without saying anything else about a method, you're not calling any method, you're just saying print the string or just return its value, that's going to be the toString method. So we're going to look at that one specifically. So for right now, you can ignore it, but we're going to look at that one. And it's actually one of the most fascinating aspects of object-oriented programming in Java. It gives you a lot of flexibility in terms of how your classes can be used. And it also has the idea of super black boxing an object. Like there, you can actually define what this object does and how it represents itself directly, and hiding a lot of the functionality within, just with that simple method called toString. So let's take a look at that method itself. Or sorry, look at the class definition. So we've got that in Dr. Java a little bit better. So we're going to go over here to the die class. And so the die class, as we've seen before, we're going to split it up into the attributes or the data, and then all the methods that define that particular class. And we're going to code it up in the same idea that we have the data up top, and then down below we're going to have the methods. That way another programmer, or you later on looking at this, don't have to go hunting around for all the attributes scattered throughout the class. All the attributes are going to be at the top, and all the methods are going to be below. Of course, it's Java, it's free form, you could probably mix them up, but don't. Keep them all nice and organized. So what makes up a die class? Well, we've got its name, public class die. So that's exactly what we've seen before when we're writing our Hello World program, public class Hello World. So the same exact syntax, but this is going to be new. We've seen it a few times in some of the early programs we've written, but these are going to be instance variables. Now we've commonly referred to them as global variables when we're writing our program classes with a main method. But these belong to the class itself, which means every instance or every object of the die class will have its own max and face value, which is actually exactly what we want for every individual die. Maybe not the max, but definitely the face value. So when you roll one die, it might land on a 3. You'll roll another die, it might land on a 6. Each one will have its own face value. So these are the attributes that the die class defines and every object will have. So a special one up here at the top though, that's just going to define what's the maximum size for this die. Because we're going to roll it and do some random calculation, so we better actually know what the limit is for randomness. The face value itself is just going to store what that value is. Very similar to the length of a string. It's just a value within it. So down below we've got our methods. Now the most curious one is this one right here. It's called the constructor. What is the constructor method? The constructor itself, and every class has a constructor. Whether you write one or not, every class has a constructor. Sometimes it's empty, it means it doesn't do anything, but Java itself will force every class to have a constructor. Now in this case, when we create a brand new object of the die class, we're going to assign the face value to be 1. So imagine taking a die out of its packaging. So you've got a brand new die that you've just bought at the store. You take it out of its packaging and you put it on the table. This defines that that die will have the side 1 facing upwards. That's what this is implying. So when you create a brand new die, you haven't done anything else to it, the face value is going to be 1 immediately. So without doing any rolls, as soon as that die object gets created, it's going to have a face value of 1. That's what that constructor is. We're going to look at constructors again, but the idea is as soon as that object gets created, the very first method that gets called is going to be the constructor method, to the point that you don't even control that. Java will enforce the constructor gets called first. And we're going to see when this happens, when we use the die class in a program. Now we've got our other methods. So we've got the roll method, So we're going to ask the object to roll itself. So the roll method, if you see, it's got a name called roll, but it has no parameters. You don't give the roll parameters. When you have a die in your hand and you're rolling it on the table, you don't give it any information aside from just saying pick a random number. And that's exactly what it does. So in this case, instead of using the random class, it uses the math.random method. So this one, math.random, returns a value between 0.0 and just less than 1.0. So 0.0 to 0.999 repeating. And then we just multiply that by max. So that gives us, it should give us, in this case, a value of 0.0 to, let's see, the max is 6, so that'll be 5.999 repeating. So just less than 6.0. Now, of course, we don't have fractions when it comes to die. We don't have like 1.5. It's either going to be side 1 or it's going to be side 2. So that's why we have to do that cast of integer. But just before we leave off, though, we do a +1. And what that does is it returns back the range of 1.0 to less than 7. So that gives us the proper range. And once we cast that as an integer, that should give us the range 1 to 6. So that's what we're finally left with this calculation. We have a face value that's from 1 to 6. So we've seen that before with the random class where we have to do some shifting. We've got to do a +1 because the range always starts at 0. But this one is actually neat because it's using another class, math, to actually do some work, which is actually pretty cool. And then once it's figured out what the roll is, it picks a random number from 1 to 6, it returns it. So there you go, there's the roll method. So every die object is going to have the ability to do a roll. Now we've also got the additional values here. We've got set base value. So this is where you can actually, as a user of this class, you can tell an object of the die class to set its value to a particular side. So what we're going to do is set the value to an appropriate side. But you'll see that there's an if statement. Why is there an if statement? Well, there's no limitation here because this is just an integer that's being passed in as a parameter. You can have negative values for integers. You could have 0. You could also have 1,000,000 as a value. But the number of sides are only from 1 to 6. So we've got a little check in here to make sure that the value is greater than 0, so it starts at 1, and that the value is less than or equal to max. So it ensures that if you're setting the value for this die, it's only going to do it with values 1, 2, 3, 4, 5, or 6. Any other value outside that range will not set the face value. The method won't fail, it just won't accomplish anything. So if I try and set a die value to -15, it won't change the die. So imagine having a die in your hand and you want to set the face value to -15. You can't actually do that because the die doesn't have a face called -15. So it won't let you do it because it's impossible. So we've also got the idea of a get face value where you can ask every die object, hey, what's your face value? So it just returns the face value. That's it. And then the toString, which we'll talk about much later. Now these two down here, or sorry, these three, you'll see that they're all using face value. Actually, the constructor is, but I want to look at just these methods. So roll uses face value, so it's setting it, it also returns it. Set face value sets the face value. It doesn't return anything because it's a void method. Set base value shouldn't return anything. The get face value, which is actually returning it, is using face value. And as we saw before, in terms of having methods share data, we have to declare that data outside. So when we had the min-max method from the previous lecture, we had to define min and max outside. We made them global variables so that the main method and the min and max method could both access this data outside. Now this hopefully makes sense of how that's going to work. So we've defined face value out here. We call it an instance variable in this format, but it's really just a global variable. So the constructor can see it, the roll method can see it, the set face value can see it, and so can the get face value. all four of these, well, actually all three methods in the constructor, they can all manipulate that same value outside. And that's actually how this class is actually going to work. Now, a couple of important things about this class. First things first, you'll notice that these two values are private. What does private mean? So private and public. So it comes down to object security. What is object security? Well, when we're looking at a class definition, for example, the die class, we're going to make the face value private, which means it can't be modified, it can't be viewed, it can't be accessed, it can't be anything outside of an object of the die class. So the only way that the face value variable can be modified is within the class itself and only by those methods. So to manipulate the face value, you have to be able to use one of the methods that belong to the die class. So you're either going to roll it to set a random value for the face value, you're going to use the set value, so you're going to give it a value. Now keep in mind it also does a bit of a check, so you can't set face value to anything you want. And then you can also see what the face value is by using the get face value. So it's the idea of security. So if we set something as private, what it means is that the attributes, if I could spell it properly, the attributes and methods defined as private can be accessed only by the methods within the object, and only by public methods, of course. So the idea is that the privacy, you're going to enforce a particular rule. Now, it doesn't matter what is private, but it can't be seen from outside. It can't be called from outside. So you can make your whole your class definition extremely secure. You can actually have very specific values. The public attributes, public itself means that you can access them. And we've seen some examples of things that are public. For example, the math class has math.py, which means .py within the math class must be public so that you can see it. So if we look at the math class itself, we'll go down here, we'll see that there are two attributes, or what are called fields in Javadoc. So there's e, which is the exponent value, sorry, the natural logarithm of e. So there it is, natural logs. And we've also got pi as well. So you can see that they are defined as public. Now, they're final because you can't change the values, but you can see them. So the math class is like that. We've also got the idea of public for the string class. So if we define a string here, name is assigned Bob. We are going to access the method called to uppercase, which will then look at the characters for the string and then return back a brand new string with the characters in uppercase. So we've got the idea of calling something like this. Within the class, though, there is no security. So within a class definition, uh, because it's within the class and a programmer is writing this, you've chosen to write the die class, you can do anything you need to do in here to modify. You don't have any security because you are the programmer. You are your own security. If you make a mistake in this class and you don't ensure the proper protection for your values, well, sadly, that's your fault. You're not enforcing your own security. But if you give your class to somebody else, you want to make sure that they do not have access to things they shouldn't. And that's why you define things as private or public. Now, everything else, though, all these other methods are defined as public. Why are they defined as public instead of private? Because we want another programmer to use them. Whether it's the constructor, whether it's the roll method, whether it's the face value method, or the get face value method. We want another programmer to be able to access them. We want another programmer to be able to get to these methods and use them. So let's go through an example where we're actually using these methods. So the book talks about an example here called snake eyes. And for those of you not familiar with rolling, snake eyes is where you roll two die. So you roll a pair of dice and they both come up with the face value of 1 showing up. So it looks like two snakes' eyes staring at you. So what we're going to do is a very simple example. We're going to define two die objects. we're going to roll the die objects a number of times, and we're going to determine if those two die objects both have rolled a 1, and if they have, we're going to add that to a counter. So this is just a little probability test program. That's all this really is. So let's actually run it before we get to it. Let's just see what it does. So what it should do is roll. It should have 10 rolls. It'll tell us the outcome of each roll, and if it is a snake eyes, it's going to add it to a counter. And then what we're going to do is output a little report here, which will be the number of rolls, which should be 10, the number of snake eyes, so the number of times both die came up with 1 face value, and then the ratio is the number of rolls to the number of snake eyes to the total number of rolls. Now, I don't know what the probability is for this, but let's see. It's 1 out of 6 for each die, so that would be that's 0.167. I'm just doing things on a calculator here. So that should be approximately 0.167 times 0.167. That should be about 0.03. So approximately 0.03 it should be the ratio. So that's 3%, I would think. Probability rules indicate that it should be 3%. So just doing some math in my head. So let's actually see what happens here. So we'll do a compile of snake eyes. We'll do a compile of our die class, and now we will run our class. And here we go. So let's see what the outcome is. So we've done 10 rolls. Let's see if we do a manual count here. None of them came up to be snake eyes. So clearly, nothing. Let's run it again. Let's see if we get any probabilities going on. Okay, in this case, we've got 1. So 1 out of the 10, so a ratio of 0.1. Let's run it one more time. And in this case, we only got a 1. So why isn't it come out to be a ratio of 0.3, which is we expect? Well, this is not a very big sample set. So the book actually had it go for 500. So let's do that for 500. But what we will do in the interim, because we don't want to count up those individual ones, we will comment out the display of each individual roll, and it should actually run a lot faster. So there we go, 0.022. It's getting closer to 0.3. Let's run it one more time. 0.036. We're around there. If we change this to 5,000 rolls, we should get something that's a lot more accurate. Look at that. Yeah, that's very close to 0.03. So about 3%. Yeah. So our program is running fairly accurately. So let's reduce that down to 10 again, 10 rolls. So how do we have our program set up? So without getting too deep into the class definition, we'll look at that in just the next virtual lecture. What we have is a file here called die.java. Now there is no main method here. It doesn't need a main method because this class definition doesn't run on its own. This is only defining die objects. You don't run them. What you do is you then use them in another program. So this program here has our attribute, which is private. We're not going to modify it outside. We have our methods. We have our constructor method, which we'll talk about. Our roll method, our set face value, get face value, and the toString, which we'll talk about much later. But here is where the magic happens, this program called Snake Eyes. So this actually has our public static void main string args. Here is our main method. Our main method defines the number of rolls that we have. In this case, we're only going to roll the die 10 times. We're going to have our outcome for each die. So every time we do a roll, we're going to store the outcome, num1 for die number 1, num2 for die number 2, and we also have a counter, which is going to count up the number of snake eye rolls, where each die has a 1. Now here is the fun stuff, right here. This declares two die objects. So you'll see the syntax, very similar to how we've done scanner scan and how we've done the string class and how we've done the random class. First, we have the name of the class. In this case, it's die. Unfortunately, that's the name of it. It would be much better if it was called live. So die, we have the name for this object. We're going to call die1. And now we're going to do an assignment here. New die. What the heck is that all about? This is the constructor. So when we're creating a brand new object, we have to call the constructor for that object. So it only gets called once when the object gets created, and that's why it's called the constructor. It sets up the object. So when we're creating this object, when Java creates this object in memory somewhere, the very first thing it's going to call, without us specifically saying, please call it, is going to be the constructor. And if we look at this die class, the very first thing it does is it sets the value to 1. So that die, as soon as we take it out of its packaging, as soon as we create it in Java, it's going to have the face number 1. So that's what that is all about. Now, if you remember, when we did use the keyword new, it returned back the memory address. So what is die1? Well, we call it an object. We call it an object of the die class. But really, die1 is just storing the memory address of where this object is in memory. And what does it look like when it's in memory? It looks like that little yellow box there. So in memory, this is going to be what it looks like. So we're going to have the data that belongs to that die object, which is going to be the face value. And we're also going to have the references to all the methods that belong to the die class itself. So that creates our die1 object. Now, because we have two dice, we have a pair of dice here, we need to create two of them. So we're going to create one die object. This is going to create it in memory, return the memory address, and store it over here to die1. And then we're going to do the same thing for the second die. We're going to create another die object, and we're going to store its memory address to die number 2. And now we have these two objects in memory, these two die. Each one actually has the value 1 facing up, because that's what happens when you call the constructor. But now we can actually start rolling them. So what we have is a very simple loop here, and this loop is going to go from 1 up until the number of rolls, which is 10. And what's going to happen inside this loop? Well, we're going to roll each die. So what we're going to ask is a die number 1, I'm going to call your roll method. So if we look over here to the definition of the die object, we go down to the roll method. What happens in that case? Well, it's going to pick a random number from 1 to 6, store it in the face value, and then return the face value. So not only does it set the die and say, I'm going to change your face value from 1 to whatever new value it is, I'm also going to return that value. And it returns back an integer. So if we look back over here, that integer that gets returned is going to get stored over here to num number 1. We're going to do the same thing for die number 2. We're going to ask die number 2 to roll itself. Now, each object has its own attribute, its own face value attribute, and its own roll method. So when we ask die number 2 to roll itself, it's going to pick a random number from 1 to 6 and store it in the face value that belongs to die number 2. So when we're back over here at the code, the face value for die number 2 gets returned and stored into num2. So die 1 has its own face value and die 2 has its own face value. Same with the humans. Each human has their own eye color. Although every human has an eye color, each human has his own eye color. So that's what we've done here for num1 and num2. We've set the face value for each die and returned that value. Now here's where we do a display. We'll talk about that one in the next virtual lecture. But what we've done here in an if statement, now we're going to check to see if num1 and num2 are the same. Did they actually roll the same value? If they did, they both rolled a 1, which means it was a snake eyes for both of them. We're going to add 1 to the count. Now, the one thing I'm going to do is I'm going to modify this if statement slightly. I'm going to comment out this one because we have a get face value method. So I'm going to use that one. So I'm going to say, hey, die number 1, get your face value. and check to see if your face value is equal to 1. And die number 2, why don't you get your face value and see if your face value is equal to 1. Because if we look back over here to the die class, we've got face value, which returns back the face value. I don't actually need to store the face value in num1 and num2. It's not necessary for the sake of this if statement, because each die remembers. It remembers what face value it has. And this is an object. An object's not going to forget itself. A string object is not going to forget its characters. So until we roll again, that face value is going to get stored. So now let's run this program one more time just to see if everything works perfectly fine. And there we go. We've rolled the die. We've got different values for each roll. Every time we've done a roll here, it's picked another random number from 1 to 6, and we've tried to see if we've got a comparison. Now again, we're only back to 10 rolls, so the number of the possibility of getting snake eyes is very low, but the fact that we got one I thought was pretty good. So that's it for this virtual lecture. We're going to keep going with the die class in the next virtual lecture, and we're going to take a closer look at the various methods and also the toString method, which is probably one of the most useful and needs to be well understood methods for classes. All right, that's it for this one.